Hi there. Let me take a few minutes to take you through the solutions to the paired T procedures handout. So we have a situation where we have 20 subjects and we're looking at before and after scores for these Spanish teachers' essentially listening ability in terms of Spanish before and after they attend this summer institute. So very important, we do not have a random sample. That's a big issue. So we really don't have a choice to proceed. We're going to have to treat it as if it were a random sample. So this is the actual independence condition, which seems reasonable, but understand I'm not convinced that we actually have independence. So question number 3, the central limit theorem doesn't apply. So that's why we had to graph the data. And if you graph the data carefully, you'll see that we don't see a lot of skewness and there aren't any outliers. So it is reasonable to believe that the distribution of the actual means for the differences in MLA scores, it is reasonable to believe that that is approximately normal. So let's go to the calculator. Again, on the home screen, we took the difference of list 2 and list 1. List 2 has the post-test scores in it. List 2 has the pre-test scores in it. And so here is the difference, post-test minus pre-test. This is the sample of 20 differences, and I'm interested in the mean difference. I'm trying to estimate what the actual population mean difference might be. So we need to look not at the distribution of list 1 or list 2, not at the distribution of the individual scores, but at the distribution of the differences. So to check for outliers, the first thing I suggested was you go into plot 1. So we needed to choose the box and whisker plot option. So our data is in list 3, that's where the differences are. And you can zoom 9 this, that's perfectly acceptable. So this automatically calculates whether or not we have outliers. We don't have any outliers here, so we're at least good to go with that. That graph also tells me that the distribution is approximately symmetric at the very least. So I personally think a histogram gives you a better idea of the shape of the distribution. So that's why I suggested that separately you go in, select the histogram option, and then once again use zoom 9 in order to graph the histogram. So there isn't anything that is really crazy in terms of skewness there. Is it perfectly symmetric? Well, of course not. But there isn't any severe skewness there that would make me think, that would suggest that the normal approximation isn't reasonable. So that means we can go on to the backside. Of course, truly, and I meant this, we really are proceeding with caution. And that phrase may sound kind of funny, but it actually is used. So we don't have randomness. We sort of have independence. The normality condition is essentially achieved. So if we want to calculate this or even consider interpreting it, we really do need to proceed with caution, or we really need to take these results with a grain of salt. So if you actually run one variable statistics, here's the mean difference of 1.45, the standard deviation, and the sample size. So remember, the degrees of freedom are one less than the sample size, and you need to use that in order to find your critical value, which should be a t-score here. We are using the sample standard deviation. We don't know the population standard deviation, so we need to use a t-score here. And that would be found either by using the inverse t command on your calculator or the INVT program. Either way, the area, remember the area that we need to enter is 0.95. Don't enter 0.9. We also need to include the 5% at the lower tail of the distribution that we are ignoring. So this is 0.95 with 19 degrees of freedom. And that will give us our critical value. Eventually, maybe 1.729 looks good. Hopefully your calculator is faster than this emulator here. So setting up then the confidence interval, our mean difference is 1.45. There's the critical value. There's the sample standard deviation divided by the square root of 20. Don't divide by the square root of 19. Use the square root of 20. So if you put that into your calculator, here are the upper and lower boundaries for our confidence interval. And when you interpret it, it's important then that you interpret it in context. So include the level. We are 90% confident. Now you should also state the parameter, that the population mean difference in MLA listening scores. So notice I was very specific, post-test minus pre-test scores. For Spanish teachers that attended this summer institute, there's a lot of context there. We always write in context. And then include your boundaries. We believe that that mean difference may be between 0.21 and 2.69 points. That's the way you would interpret the confidence interval. And just as a side note, for practical purposes, wow, if you attend a summer institute and the 90% confidence interval for the mean difference in your score after attending compared to before attending, if your score might only be going up, gosh, look at this. Within this confidence interval, there are really small values like maybe 0.3 points or 0.5 points. There are lots of very small values that could be candidates for the true population mean difference, or in this case, it really represents the increase in your score. You're not seeing a whole lot of increase for so much work during the summer and so much time invested. Something to think about, although of course this is all with a grain of salt because we don't have the randomness condition satisfied, and independence may be satisfied. That's somewhat skeptical. So even though you can create and interpret a confidence interval, thinking about what it means in a practical way is important, and then you have to go back to making sure, have my conditions really been satisfied before I think about making a practical conclusion by looking at this confidence interval. Hope this has been helpful.